we measured central angle, like this. The distance around the center is 360. And if you have a pentagon with 5 sides, then you have 5 angles, 5 central angles. So anyways, in every case, you take the 360 degrees all the way around, divide by the number of sides, which is also the number of angles, and you get the measure of the central angle. The central angle and the exterior angle are the same every single time in one of these regular polygons. And it turns out that if you add the central angle and the vertex angle, central angle, here's a vertex angle, here's an exterior angle. The exterior angle B plus the vertex angle C, if you add those together, you get 2 angles along a straight line. That's 180 degrees. So if you add the vertex angle and the exterior angle, these two added together will be 180 all the time, every single time. And these two get 180, these two get 180, and so on. So if you know the central angle is, or if you know the exterior angle or the central angle, you can determine the other, because these two are the same. The central angle and the exterior angle are always the same. And then to figure out the vertex angle, just figure out what you have to subtract from 180, subtract either the central angle or the exterior angle from 180 to get the vertex angle. So, and then down at the bottom, we looked at a kind of formula that tells us if we have a regular polygon of any size, like 120-gon, like this example, you just take 360 and divide by the number of angles or the number of sides. And then these other formulas were also used. Notice that these two formulas are the same because they get the same measure. And then the vertex angle is just 180 degrees minus this one, or 180 degrees minus this one. Okay, so yeah, it looks like you guys are doing a good job on the problem number 1. So those are the general formulas, and if n is 120, 3 degrees, 3 degrees, and 180 minus 3 degrees is 170. So yes, that is correct. Choose any vertex, anywhere, and then identify the shapes that go around that. So there's a square, and a hexagon, and a square, and a triangle. Number of sides of each of those. No matter where, if this is a correct tessellation, no matter where you put the vertex, you're going to have a 4 and a 3 and a 4 and a 6. 4 and a 3 and a 4 and a 6. Any vertex, if you go all the way around it, you'll get those same 4 shapes at every vertex. So name those shapes at each vertex. How many angles are there at each vertex? What are the measures of those? Again, all the vertex angles are right in this column. Vertex angle for a triangle, vertex angle for a square, vertex angle for a hexagon. Let's take a look at this. It says to use similar triangles in here, so what they're suggesting is that there are 2 triangles inside this shape that we can orient in such a way. I do notice that this darker, littler triangle in here has a right angle there. And so if I just took this triangle and just kind of rotated it like this and just flipped it up, I think it would be oriented in the same way as the bigger triangle. So let me try to write these down over here. So I'm going to leave the big triangle oriented the same way that it's oriented, right here. So here's the big triangle. We know that this side down here is 127, and we know that the hypotenuse of the big triangle, that's the 130. All right, so I'll call this side here X. And here it is in our diagram. Now I know I can find that value of x if I need to, because it's a missing side where I know two of the other sides in a right triangle, so I can use the Pythagorean theorem here to find that x if I need to. Now let me write the other, maybe I'll write right underneath it. If I take this smaller triangle and rotate it up, and then so that it's kind of sitting on top of the hypotenuse here, and then just rotate it a little bit, this little triangle will look like this. So there's the right angle here. I know this bottom side, if I rotate it up, is 80. So this side is 80. And this side right here, the one they have the question mark on, that one there is the hypotenuse of the smaller triangle here. So the question mark there is the hypotenuse, it's this one right here. Now it says find the missing side, and so that would be, I guess, what the question mark is. So we're going to find the question mark, and we can do that because this little angle down here is this angle and it's this angle both. It's the angle of the big triangle and it's the angle of the small triangle. And since these right angles are the same and these angles are the same, that means that these angles here also have to be the same. And when the three angles of a triangle are all equal, then we call those triangles similar. And so we can write a ratio to solve for the missing side. It would look something like this. If you take the 127, which is the horizontal side, and divide by the hypotenuse, 130, this would be on the big triangle. The theorem says that these ratios of these sides are in proportion. So this ratio has to be the same thing as 80 over our missing side. So solving that proportion is what's going to give you the missing side. So 127 times question mark equals 80 times 130. And then you'll probably want to get your calculator out on that one. So if I divide both sides by 27, 80 times 130 divided by 127, there's the 81.889 that I wrote down as the answer, rounded to 3 decimal places. Okay, so then they want the area of the small triangle. We now know that this side is 81.890, but if we want the area of the small triangle, we've got the base, we do need the height. And then the area of the small triangle would be 1/2 times the base times the height. And so we need to find the height, but we could find the height with the Pythagorean theorem. And then once we find the value of the height, we can put it into this area formula to find the area of the triangle. The perimeter of the big triangle, well, that's the distance around. So if we want to find the perimeter, we have to find the value of x. So go ahead and find the value of x and then add those 3 sides. All right, so there's 2 Pythagorean theorem problems built in here to answer these last two questions. For the problems down here, if possible, be sure to include the units. Units are all in inches here. So you want to make sure that if you have just the distance around, the unit is inches. And if you have area, the units are squared units. Here, this one here is all in meters. And this one over here, there's no mention of units at all. One hint about the circle problem over here. You need the radius. in order to find the area and the circumference. Tells you that the point 50 right there is on the circle. So if you wanted to, you could construct to figure out that radius. This right here is directly above this point, so that's the x value of 2. So that means the distance from 2 to 3 is, or 2 to 5 is 3. So that's the length of that side up there. And then this vertical side goes from 0 down to -3. So this side is also 3. So if you know that this side is 3 and this side is 3, you can figure out the radius by using the Pythagorean theorem. So in the problem so far, you weren't asked anything about the Pythagorean theorem, any questions specifically, but in order to actually find something that you were asked to find, you'd have to use the Pythagorean theorem. So there was a question about the area of the triangle here. So the first thing you have to do is to find the value of h. So we're going to use the Pythagorean theorem. H squared, small side, plus bigger side squared equals the hypotenuse squared. So it looks something like this. Now this is rounded, and so therefore we may have some rounding error on this. But 80 squared is 6,400. And yeah, okay, so here's a good example. I'm going to square this number here. And then if I square the 81.890, see, it's a little bit different. All right, so just keep that in mind. I'm going to use this number, the 6705.972 number. I'll subtract 6,400 from both sides, and that will give me h squared equals 305.972. And then if I take the square root of both sides, h is going to be equal to the square root of that number. So it looks like 17.492. So that's the missing side. So Pythagorean theorem in this triangle to find the h. The calculations are not nice and easy because we have these big numbers, because they're decimal numbers and so on, but the process is still the same. So 17.492. So since we have the three sides, we could add these three to get the perimeter. Our problem says, let's find the area of that small triangle. So the area is 1/2 base times height. So 1/2 times the 80 times the 17.492. And so you just punch that onto your calculator. And I get 699.68. So even, I think probably I didn't round that big number to get this, but it's close. 699.68. For the third one here, I'll magnify it a little bit. If you want this diagonal distance here, you can create a couple of sides of a right triangle and then deduce from these 2 points what each one of these lengths have to be. They have to be 3 and 3. Now this length here is the distance from the center to the circle, so that is the radius. Now the area for a circle is pi r squared. So all we would need to find is the r, and the only way to find it is by using the Pythagorean theorem here. smaller side squared, or one of the legs squared, the other leg squared equals the hypotenuse squared. So 9 plus 9 equals r squared. R squared equals 18, so r equals the square root of 18. And for the circumference is 2 pi r. There's another formula. So you can get these answers if you know r. Here, r squared is 18, so pi times 18 is 18 pi. And this would be, if you use pi to be 3.14159 and just multiply it by 18, you get something on the order of this. And we don't have units on this one, but if we did, there would be whatever that unit is squared, square units. And for C, we have 2 pi times the square root of 18. And as a decimal, that one is 26.657. And this would be units, not square units, because it's a unit of length, the distance around. How would you find the area of the figure? Okay, so you've got, if we've got this line drawn here, you could figure out the area of this first rectangle, and then you could figure out the area of the second rectangle, and then add them together. And since they're rectangles, what you need is just the measure of the length times the width. So for this area, you're just going to multiply 6.5 times 4, and that would give you the area of this rectangle. This one here, it looks like the width is 3.5 meters and the length is 9. So you could also figure out the area of the vertical rectangle here by just multiplying 3.5 times 9. And then once you get the area here and the area there, you add them together, and you should get something like 57.5. It's an area measure, so it has to be square meters. Now, perimeter here, I really should put in, in quotes, because it's not kind of the perimeter in the standard way. It really meant, if this was an area of land and you wanted to walk around the entire perimeter of the land or the field, then what would it be? And it's the same over here, distance all the way around. Yeah, so perimeter here, since this side is 3.5, that makes this side down here also 3.5. So that length is 3, and that one there is 6.5. It's the opposite side of the rectangle. 4 here. Oh, I got to figure out that one. 3.5, 9. Got it, got it, got it. So the only one I don't have is this GH here. And so here's what we're going to do. We're going to say this length from F to E is 9, but the distance from here to here, you would take this 4 and this 3, and so that length is 7. This is 3, and this is 4. Together they make up 7. But the whole thing is 9. So this side right here must be 2, which makes this missing one over here also 2. So the first part you want to do is just to, try to make sure you have lengths assigned to all of the, all of the lengths that you're going to walk. And then you just add them together. So if I start right here and go in this direction, I have 4 plus 6.5 plus 2 plus 3.5 plus, I'm going all the way down here, so I'm going to add 9. And then there's another 3.5 at the bottom. Back up is 3. And then finally, till we end is 6.5. You have to add all those to get all the way around. I get 38. And this would be in meters, because all of those units are in meters. what's suggested here is that the center of the circle is the point 2, 3. So in the Cartesian coordinate system, this is the point 2, 3. And down here, it also says the point 5, 0. That point is on the circle. So if you knew the length from the center to this point on the circle, that length right there is known as the radius. If you can find that radius, then you can find both the area and the circumference. So the question is, how far do you have to go up from this point to get to, and how far do you have to go over to the right to get to this point? We'll start with the vertical distance first. You can look at my picture up here. If you go from this point that has a y coordinate of -3, if you go from -3 up to 0, that distance you've traveled is 3. So this vertical length is 3 up to the x-axis. I stopped at the x-axis because this other point is sitting on the x-axis. Now I want to go from here. Now this is 1, 2, 3, 4, and then there's 5. This is 2 because the x-coordinate of that point right there is 2. So 1, 2, and then we start the length of the triangle. 1, 2, 3. So 3. So from this point to this point, we go up 3 and over 3, and then it forms a right triangle, and the missing side is the radius that we're after. So we can use the Pythagorean theorem to find it. And 4a, so the 12 is not helpful, but down here, this is 10, and this is 8. So this area in here is 8 inches times 10 inches, which is 80 square inches. And this triangle, 2 would be the base and 8 would be the height. So the area of the triangle is 1/2 times the base times the height. And that's equal to 8. So does that make sense? Yeah, it really doesn't make sense. It doesn't look like it's drawn to scale because it doesn't look like this area is 10 times as large as this one. But, so it's not drawn to scale. But this one is 8 square inches, and this triangle is 8 square inches, and this rectangle is 80. 8 and 80, add them together to get 88. Yeah, this box is a small box, right? 4 inches by 5 inches. It's more like a 5 inches. No, that's about right. It's a kind of a very small carton of ice cream, I have to tell you. But the volume is 4 times 5 times 8. So that's 160. And that's cubic inches. Length times width times height. And this one costs $4.99. A second container is a cylinder. Has a height of 7 inches and a base radius of 3 inches and cost $5.99. So just like we calculated the volume of the ice cream in the box, we'll also calculate the volume of the cylinder. So if you don't have these memorized, then you'll want to pull out your formula sheets. Oops, that's surface area. Here's the cylinder, right, circular cylinder, and here's the volume. The area of the base is pi r squared times the height. Area of the base times the height. Pi r squared is the area of the base because it's a circle, times the height. So we have pi, and then r squared times h. And because of the pi in there, you're definitely going to want to use your calculator on this, get a reasonable estimate. So 3 squared is 9, 9 times 7 is 63, so 63 pi. All right, so that's 197.92. All right, now if you see these two containers, it might not be clear to you which one has the most ice cream in it, but clearly this one does. It has 30 cubic inches more. And if your bite sizes are an inch by an inch, gives you 30 additional bites over in this container. But it's a little bit more expensive. It's $5.99 versus $4.99. It says, which is the better buy? Okay, well, you can figure it out in terms of, what is the cost per bite, for example, and whichever one gives you the cheapest cost per bite, then you might want to say that one is the better buy. A lot of times in stores, they actually calculate the unit price for you, and they say something like, this is 13 cents per bite or something like that. All right, so we'll calculate the cost per bite. And the size of a bite, the cost would be a dollar amount. And the bite would just, let's say it's just one, since our units are in inches, let's say it's 1 cubic inch. So, I mean, that's a big bite of ice cream, 1 inch by 1 inch by 1 inch. All right, so let's take the cost of each one. So first of all, the box. If we take the cost, which is $4.99, and divide it by the area, 160 cubic inch, we could figure out the cost per bite of ice cream in the box. And if we do something similar for the ice cream in the cylinder, it's $5.99, but we have 197.92 cubic inches. I mean, there are probably other ways to figure this out, but let's figure out what it costs per bite. Cost per bite. We're just going to take this number divided by this one. So 4.99 divided by 160. All right, so that's about 3.1 cents per bite. So 0.031. So for this one, we're going to say 3.1 cents per bite. And for this one over here, $5.99 divided by the 197.92. And that one is 3.0, about 3 cents per bite. .030. So this one here is 3.0 cents per bite. And I guess you could reason that, I mean, this is generally the case, right? I mean, if you buy containers in bigger quantities, and this one's a bigger quantity, it has close to 200 cubic inches, where this one only has 160. When you buy things in bigger quantities, they usually charge you less per unit. And so these numbers are usually on, some of the stores, they'll give you the unit price so you can actually compare. But, so I would say that since the ice cream in the cylinder costs less per bite, plus you get more, that maybe the cylinder is the better buy.